So remember when we were talking about the pizzas and we had to figure out how many pizzas you could possibly make? Do you remember doing that? You had to figure out what was going to stop you from making more pizzas, and you found out that that was sauce. That would have been what limited you from making more of those items. And so that's what we're talking about in terms of something being a limiting reactant. It's limiting you or stopping you from making more of the material that you, or more of the product. So the amount of product depends on the reactant that is limited. The limiting reactant limits the extent the reaction and determines how much of the product you can make. The portion of what's left over then after the reaction stops of those reactants is called the excess reactant. All right. I have provided for you, as I did yesterday, a detailed guide on how to do these limiting reactants. You'll find these at the end of your notes, and it looks something like this. So you're going to take and you're going to follow through these steps. This is a step-by-step guide showing you how to do each one of those problems. I'm going to take you through that on this problem starting out. Okay? I'm going to give myself just a little bit more room to write here for you guys. Okay, so when you start out, you always start out with your balanced equation. So put your balanced equation over each one of the cells. Who's this from?
Mr. Hammond. Wait.
No, I don't think it's Mr. Hammond.
I don't remember. One of the counselors.
Okay. The reason why I know it's not Mr. Hammond is because Mr. Hammond is in DC right now.
Wait, who's Mr. Hammond? Is he the other
chemistry teacher?
Oh, oops. He was asking me about which chem teacher I had, and that's the only name I remembered from that.
All right, so we start with our balanced equation here. We have to take, now we don't have one of these in excess. Remember before they gave us one and we just made the assumption that the other one was in excess? Now we've got to figure out which one that is. So we're going to go here and we are going to figure out which one of these is limiting. So the first thing you have to do is you have to turn these grams into moles because we can only put moles in the table. So I'm going to take this 200 grams of sulfur, that's S8. I'm going to divide that by the molar mass of 8 sulfurs. So the molar mass of 8 sulfurs is, not have that written down. There it is, 256.8. So I divide that out. It ends up being 0.779, and that's what I'm going to put in the table here under sulfur. Then I'm going to do the same thing for chlorine. So my chlorine is 100 grams. I need to divide it by the molar mass of 2 chlorine. So it's 35.5 times 2. And when I do that, I come out with 1.41. So I put that in my table. This is the division between my products and my reactants. My products, I don't start out with any. All right, anybody need another minute to get that copied down? The next part, this is nothing that's terribly new, but the next part is going to be. So I need everybody with me for this next part. All right. Any questions about where any of those numbers came from up there? All right. So the next thing that we are going to do is we are going to take this, we're going to go up into the cloud the way we were before. So 0.779 divided by 1 is 0.779. I'm going to take this and I'm going to make another cloud this time. So to get this cloud value, what do I have to do? Right, I have to take this amount and divide by 4. And that ends up being 0.352. All right, did I lose anybody there? Anybody not know how I got those numbers?
Wait, so if we have another value, or wait, why did the 1.41 be divided?
Because this got divided too. It got divided also, but it was divided by 1. Remember, we have that coefficient that's there, but that coefficient is a 1. We just don't write the 1 down.
So are we dividing them both now? Because
you divide both of these by whatever the coefficient is. So for this one, we divided it by 1, which is the same number.
Well, I get that. I'm just saying, like, yesterday, or I don't know how many days ago, we would only divide that one. So, like, for the...
Because the other one we told you was excess. Okay. Now we're not telling you which one's excess. You've got to figure it out. Yeah. And that's what I'm getting ready to show you right here, is how to figure out which one is in excess.
So if we have that number, like 1.41, you're just going to divide it by
its coefficient.
All right.
You divide it by its coefficient, not any other coefficients. The one that's right there.
And how did you get 1.41? Isn't that?
I took the mass that they gave me of the chlorine here, which was 100, and I divided it by 2 because it's Cl2.
Yeah.
So Cl2 off the periodic table would be 35.5 plus 35.5, which is 71. And I divided 100 by 71.
And that's the moles, right?
That's the moles. Yep. This is moles of Cl2. And that's what I put in the table here. All right. Everybody good up to this point? You know where all the numbers came from. You know how I got everything. All right. Now, to figure out, listen to me. This is a good, important step. Aaron, are you listening?
Oh, yeah. Oops.
At this point, you have 2 clouds. You see that? You need to get rid of all but one of them. The way you figure out which one you're going to keep is you find the lowest number? Which number is lower here? Yes, this is our lower number. We get rid of this cloud. It's gone. You can erase it off your paper, do whatever you want. You get rid of everything but the smallest cloud. That is gone now. It's out of there. This is my cloud that I want to keep. The smallest cloud is what you keep. Then you proceed the way you've been doing for the past few days. Okay? Take that cloud, go down through the coefficients, multiply through the coefficients, multiply through the coefficients. So this guy, I'm going to subtract, I'm going to add, multiply through my coefficient. This is going to be 0.352. This is going to be 1.41, and this will be 1.41. Aaron, are you drawing or are you doing your work? To figure this out, you subtract. So 9, that would be a 7, that would be a 2, and this would be a 4. So this is how much you're going to have left over. If you get to this point and you have a negative amount here, then you chose the wrong cloud.
So no numbers on this are ever supposed to be negative?
Not in the after, no. They could be 0, but they should never be negative. If this after line is negative, then you goof something. Go back. Figure it out. Now, what they wanted to know was the mass of this guy. So we're not done with this problem because we're not in mass yet. We're in, what is this value in? What units?
Moles.
Moles, yeah. Only moles in the table. Only moles in the holes. That's where moles live, right? We live in holes. These are our holes. Only moles in the holes. All right. So I've got to take this mole value and I need to multiply by the molar mass for S2Cl2. That ends up being 135.2. So if I multiply those two things together, I get 190.6, and that would be grams of S2Cl2. Right? Any questions on that problem before we do another one?
And the 135.2 is just all of,
it's 2 sulfurs, which are 32.1, and 2 chlorines, which are 35.5 each.
So what would that be called?
Molecular mass or molar mass?
Molecular.
Called the molar mass. Actually, it's a molar mass because it's the grams of 1 mole of this. All right, good. Ready to move on? All right, let's try another one here. This one, the equation for this is P4 plus 5O2 yields P4 O10. I'm going to take my 25 grams of phosphorus I'm going to divide it by phosphorus times 4 off the periodic table, which is 124. And that's going to give me 0.202, and that's moles of P4. So I'm going to put that right there. My oxygen then, I'm going to take, and I'm going to take the 50 grams of the oxygen. So 50, divide that by 32.0, and that's going to give me my moles of O2. That's 1.56. Okay, I want you to tell me what the values are for each of these clouds and which one of these would be my limiting reactant. So you're going to take this and figure out the two cloud values and then figure out which one's going to be the limiting reactant there. How are we going to figure out the cloud values here? What do we do to figure out cloud values? Divide it by the
whatever it's called. What's it called? Coefficient?
Divide by the coefficient. So this one should be easy to do. You can probably do that hopefully in your head. So 0.202 here. And then this one I need to divide out. I need to take this value and divide by 5. And remember, you want 3 sig figs in your clouds, and you want at least 3 sig figs in your table. All right, we have our two cloud values. Which one am I going to keep? The one for phosphorus or the one for oxygen?
Phosphorus.
Why?
Because it's a smaller value.
Right. So we're going to get rid of this guy. I'm going to get rid of him, and I'm going to keep this one. And then we're going to proceed the way that we have been up to this point. So I'm going to take this guy, and I'm going to distribute it through from the cloud through my coefficients down to here. This guy I should have written in as a 0. These on the product side, we're going to add. We're going to subtract our reactants. And then we're going to continue from there. This is my dividing line between my products and my reactants. So see if you can figure out how many grams of this. So we want to know grams of this guy. And we want to know grams of your excess reactant. So figure out which one of these is in excess. And from there, figure out the grams of that. So how many grams of this, grams of this. Playing along at home, or you got this done already? You finished this one? Okay. Anybody have any trouble getting their table filled in? You have trouble with your table? You got your masses?
So then it's just
You
30.
got the mass of this. You got the mass of that.
Times 4. Yeah. So I did that. Times 10 equals 60. So then it's 284. No, for the oxygen.
But no, you just, oh, that, okay, I got
Yeah,
it.
and then
Okay,
I just wrote
okay.
that there. It's 280. It's 284. Times 0.0. Right. 284 times. No.
All right, so I found that my molar mass of this guy is 284. So I'm going to multiply this by 284. And I end up with 57.4 grams for the P4010. For here, I need to multiply this by 32. So 32 times 0.550 equals, that's 17.6 grams for this guy. All right. Questions about that? Anything that doesn't make sense? All right, let's try another one. So this one, they gave us our reaction up here. We've got 6Na plus Fe2O3 yields 3Na2O plus 2Fe. So you've got 100 grams of sodium and 100 grams of this guy. Figure out which goes where and which one you end up with for your limiting reactant. So take a minute or two to do that. I will come around and see if I can help you. I'm going to start with 100. Find the molar mass of that. Right here for sodium. Divide that by the molar mass for sodium. 200, yep. So you need to find the molar mass for sodium. It's right here. It's 23.
What did you get for 100 divided?
100 divided by 23.
And sodium? It's like 6, right?
Get most of the numbers. Yeah.
And you have to, no, I said, you get 36. It's 100.
Divided by 23.
This was 100 by 23.
It's the molar mass for sodium.
Oh, oops.
And do I do the same thing for like the next part?
I forgot that part.
You have 3 options. And then add those 3.
So this ends up being 4.35 here. And this guy, I have 100 grams of him as well. So we're going to divide it by its molar mass, which is 159.6. And that ends up being 0.627. Oops. 27. There we go. Need to figure out my clouds. I'm going to have a cloud here for my sodium, and I'm going to have one here for my iron 3 oxide. Whew. So this 4.35, I'm going to divide that by 6. Can't read my handwriting. .725, and this guy, of course, is 0.627. Anybody having trouble up to this point? All right. So then I'm going to figure out which cloud I'm going to keep. Which cloud do I keep? Sodium or iron oxide?
Sodium. Or wait, iron oxide.
Iron oxide, right. So I'm going to get rid of this guy. He's going to go away, and I'm going to use this for all of my work from here on out. So this one I end up taking and I multiply it by 6. I'm going to subtract here because this is a reactant. I'm going to subtract here because this is a reactant. This is my dividing line between my products and reactants. I wouldn't have started out with any of these. I'm going to end up making oh, I looked at the wrong one. Hold on. That's not right. That doesn't look right. There we go. There we go. That looks better. All right. So over here, I'm going to subtract. And over here, I'm going to add. Okay. Then they wanted to know which one was my limiting reactant. Whichever one has the 0 here, whichever cloud we kept, that's going to be your limiting reactant. Which one is my excess reactant? That is the one that I had stuff left over here. Then they want to know the mass of the iron produced. So they want to know the mass of this. So we're going to multiply that by the mass off the periodic table for iron. 55.9 is what I need to multiply this by. And that's going to give me my grams of iron. And there we go. 69.97 is how much of that we're going to have. And then over here, they wanted to know how much of this was left over. So 0.59 times 23. That's going to end up being 13.57. Anybody have trouble with that one?
It's okay.
Hmm.
Isn't it supposed to be 55.8? Because it's 4.
It's 55.85. So that rounds to 9. I don't know. I guess I'm looking at the AP.
It's 4. 5.
Oh, on yours. Okay. I was looking. So the AP periodic table goes to the hundredths place, and that's what I was looking off of because this one is covered up. So yeah, it 55.8 would be on yours because yours is 55.845. AP's is 55.85 because they rounded this one up already. So then that rounds that to a 9. So that's why I was looking at this. I don't give you this one because they don't write a lot of the stuff on it that you guys need, like the names of stuff. All they do is write the symbols, and so I don't want to give you that one. I want to, yeah. But yes, you're correct with what you have, and I was correct with what I was looking off of, but it's not the same as what you have, so that was my bad. All right, questions? Anything else? Okay, let's try another one. Oh, photosynthesis. All right, so we have our equation here for photosynthesis is they want CO2 listed first plus H2O. There's going to be 6 of these and 6 of these. That's going to yield C6H12O6 plus 6O2. There's your balanced equation. See if you can get the masses for these. Stop me as I'm walking by. Ask me questions. Let me help you with this stuff.
See how any of the grams are put in moles? Which one would you use for water?
So for this one, you're going to use the one that's carbon dioxide. So 88 grams of CO2. So you're going to take that and divide by the molar mass of carbon dioxide. These are like word problems from math gone crazy, aren't they? It's just like 8 word problems in a minute.
You don't use,
That is times 2.
Carbon dioxide, the molar mass of that is 44. You've got 1 carbon and 2 oxygens. Carbon is
That's
12.
how it's drawn.
12 and 32 is 44. So 88 divided by 44 is going to give me 2 moles of CO2. And then for my water, I'm going to have 64 divided by 18. That's going to give me 3.56 moles of H2O. Okay, then we're going to figure out our clouds. Take a minute to figure out your clouds. Anybody not able to get the 2 and the 3.56? Good. Do you get your masses of each thing? When you get done, they're all in moles, and then they wanted mass. So I'm going to divide 2 by 6. So 2 divided by 6 is going to give me my moles here, or my cloud value, which is 0.333. 3.56 divided by 6 is going to give me 0.593. I'm going to get rid of this cloud and leave me with this one. So then figure out how you're going to distribute that. No, it's the coefficient. When you come in and out of the cloud, it's just the coefficient.
Because whenever I see a small number like that, I just like, no, and then this is
Yep.
so then,
It's actually 0.2. Yeah, I'm by 6 or
You get your 3 here. Multiply that by 6 to get this number. Same as this, because you divide it by 6 to get here. So if you multiply by 6, you're going to get the same number. It's going to be minus 2. This one you're going to multiply by 6 to get this number. You just did that. This times 6 is the same as this times 6. This is going to get multiplied by 1. Go down to here. These would have started out as zeros. Zeros there. This times 1 is that value. Okay. And this times 6 is that value.
Two again. This times 6 is the same as this times 6 is the same as this times 6. Okay? Plus 2. That's a 5, right? And now you can figure out your mass is 3.
All right, so here I've got, I'm going to multiply by 6. So this is going to be minus 2.00. This is going to be minus 2.00. These are going to be pluses. So I'm going to have plus 0.333. And this is going to be plus 2.00. So I've made 2 moles here. I will have made 0.333 moles here. I'll have 1.56 moles left over and none here. So then, when I get done here, I need to figure out my mass of each of these. I won't have any of this left. I'm going to multiply this by 18. I'm going to multiply this by 180, and I'll multiply this by 32. So my total amounts here for each of these end up being, the glucose is going to end up being 59.9 grams. My oxygen is 64.0 grams. And my excess amount here is 28.1 grams. Okay? So you have your 11.6 for homework. And Jocelyn, Yoel, and Mario, I still need your lab. If I don't get it by tomorrow, I'm not taking it.